We say that the thermodynamic process can be occurred only when the system is changing from its initial state to the final state. There will be no flow of the heat will be happens between the system and surrounding. Such process we call it as what? Adiabatic process. The energy is neither be created nor be destroyed, but it can be transferred from one form to another form. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, again we are going to discuss with our next part of the thermodynamics. In our last discussion, we were discussing about the introductory part to the thermodynamics, where we have understood that what is the thermodynamics, what we are actually going to study in the thermodynamics unit. And also we have understood about the types of a system, and also we have understood the common terminology which we are repeatedly used in the thermodynamics. In addition to that, we also talk about the thermodynamic properties. Today, let us move on to the next topic of this unit by understanding the types of thermodynamic processes, change in the internal energy of the system, and also the internal energy of the system can be altered by either by changing the heat, either by changing the work done on the system. That can also be studied. And also, we are going to discuss with the first law of thermodynamics, which is also known as law of conservation of energy. First, we will understand the types of thermodynamic processes. Okay, we say that the thermodynamic process can be occurred only when the system is changing from its initial state to the final state. That is said to be thermodynamic process. When we say it is a process, only when there is a changes in the initial state to the final state, then we say it is a thermodynamic processes, and we call with that processes with the different names also. First, we'll see with the isothermal processes. When the temperature of the system remains constant during a process, we call it as isothermal process. When we say it is isothermal process, only when the temperature remains constant for that processes. Okay, and heat may flow in or outside of the system during the isothermal process. In this process, what will happen? Either the heat may goes inside the system or it leaves outside to the system. The temperature of that system will be remains constant. Such systems are said to be isothermal processes. Next is adiabatic processes. No heat can flow from the system to the surrounding. It is said to be adiabatic process. Remember, in the adiabatic process, either there will be no flow of heat from the system to surrounding or from surrounding to the system. So, what will happen? There will be a no exchange of heat. There will be a no exchange of heat which is happening between the system and the surrounding. That is said to be adiabatic processes. Next, we have isochoric processes. It is a process during which the volume of the system will be kept constant. So, whereas in the isothermal process, we kept the temperature as a constant. Whereas in the isochoric process, we are keeping the volume as a constant. Such systems are said to be, or such process we say that it is the isochoric process. We have one more process known as isobaric processes. It is a process during which pressure of the system will be kept constant. So that such systems are said to be isobaric. Remember, in the isothermal processes, what we are doing? We are keeping the temperature as a constant, so that there will be an exchange of the heat inside or outside of the system can happen. Whereas in case of adiabatic processes, we understood that there will be a no exchange of or no heat will be flow inside of the system or to the surrounding or from the surrounding to the system. Whereas in the isochoric process, we have understood that we are keeping the volume as constant. Whereas in the isobaric process, we are keeping the pressure as a constant. Such process we call it as isobaric, isochoric, as well as with the adiabatic and the isothermal process. Remember, during this process, the system can change its state from its initial state to the final state. Okay? And also, we call some of the processes as in a two-way. One is reversible process and the one is irreversible process. Suppose if I'm doing any chemical reactions, what will happen? It goes in a forward direction. If I pull that reaction back, such reactions are said to be reversible reactions or reversible process. A process which can reverse at any instant of time by increasing the opposing forces by infinitesimal amount. That is said to be a reversible process. Suppose if I am carrying out any reactions, imagine my reactant A and B is giving rise to C plus D. I am forcing this reaction to come back with its original state so that I am pushing this reaction backwards. Such reactions are said to be reversible processes. Okay. Next we have irreversible processes, a process which can be carried out rapidly so that system will not get the chance to obtain the equilibrium. That is said to be irreversible process. For example, if A plus B is giving rise to C plus D, continuously if you apply process which is carried out rapidly so that the system will not get the chance to come back to its original state. Such reactions or such process we call it as what? Irreversible processes. So, hope you all understood with the irreversible as well as with the reversible. Okay. Next, we have the change in the internal energy of the system. Remember, internal energy is nothing but a total energy which is present inside the system. Okay. It may be in the electrical manner, it may be in the mechanical manner, or it may be with any forms of energy. Suppose if I do the work onto the system, what will happen to the internal energy? We'll see now. Okay. Change in the internal energy of a system by doing the work. The adiabatic process is a process in which there is no transfer of the heat between the system and surrounding. Let us bring the change in the internal energy of the system by doing some work on it. So, we are considering what? We are doing the work and it is an adiabatic process. We know that adiabatic is a process where there will be no flow of the heat will be happens between the system and surrounding. Such process we call it as what? Adiabatic process, and we are considering the adiabatic process to that we are doing the work done so that we need to change the internal energy of the system. Understood? So, let us consider the initial temperature of the state of the system as TA, and also what we are going to alter? We are altering what? Internal energy. So, internal energy can also changes from UA, and this is a temperature TA at the initial state. Okay. We can change the state of the system by doing some of the mechanical work or with the electrical work. Now, I'll do some mechanical work to this system. What will happen? The temperature of that system can also changes from TA to TB, and also internal energy can also changes from UA to UB. Now, if you see that this is our final state, what it is happening? When you just work done onto this system, there will be a change in internal energy as well as with the temperature. And you can see that this TB is always greater than TA. Correct, no? So, TB is a temperature of that reactant in the final state, whereas this is the temperature of the reactions at the initial state. Or you can say that the delta T, which is equal to TB minus TA. Then what does this delta T stands for? Delta T stands for change in temperature. So, After doing some work, what will happen? The temperature will be changes from its initial state to the final state, and that can be calculated simply by writing with the delta T, which is nothing but a change in temperature. Similarly, you can write with the internal energy, that is change in internal energy, which is equal to UB minus UA. What does UB stands for? It is the internal energy of a system at the final state, and this is UA stand for internal energy of a system at the initial state. This is how, just by doing work, by considering the adiabatic process, the internal energy of the system can also be get changed, and the internal energy which is also get changed. Okay. Given amount of work is done on the system, no matter how does the work is done and produced the same changes in its state, it is measured by in the temperature of the system. So, as we have just understood that this thermodynamics, it always deals with the state of the system at the initial state as well as at the final state. It does not depends upon how much quantity of the work you are applying on the system. Correct? Now, how much work you are doing to alter the initial state of the system. It talks only about the state of the system. Okay? For the adiabatic work, we can rewrite it as WAD, required to bring about the changes in its state. It is equal to the differences between the values of the internal energy, that is depicted as U in the one state than that of the other state. So, we can rewrite this as change in internal energy, which is equal to U2 minus U1. What does U2 stand for? This is a internal energy of a final state or with the end state. This is the internal energy at the initial state, and it is equal to the work done at the adiabatic processes. So, U stands for what? Internal energy of a system, and delta U is nothing but a change in internal energy of a system. So, by looking at this example, we can clearly understand that this thermodynamics which depicts only upon, or it will be tells only about the state of the system, not upon how much the quantity of the heat or the work is done onto the system. And also, just by doing the work, by considering the adiabatic process, we have understood that the internal energy of the system can also changes from one state to another state. Okay, and work done on the system by adiabatic processes can be signed in the known, or it can be designated in a two-way. That is, if the work is done by the system, it is depicted as negative way. If the work is done on the system, it will be represented as positive way. So, the sign conversion is very, very important to understand in the thermodynamics. If it is done by the system, it is negative. If it is done on the system, it is positive. Next, we have heat. The internal energy of the system can also be changed by the transfer of heat from the surrounding to the surrounding or vice versa. This change in energy is a result of temperature difference, and it is called as heat. So, what you can say? So, the change in internal energy of a system can also be done by changing the heat or by applying the heat, and also by doing the work. So, this is the expression. We can clearly understand that we can change the internal energy of your system either by doing the work or by supplying the heat to the system. We will take an example so that you will understand. The water is taken at a temperature TA in a container having thermally conducting walls, which will be enclosed in a huge heat reservoir at a temperature TB. The heat is absorbed by the system is Q is equal to TB minus TA. In this case, the change in internal energy will be equal to delta U is equal to Q. No work is done at a constant volume, so that heat changes and the heat conventions will be written like this. So, if the heat is transferred from the surrounding to the system, it is depicted as positive sign, and from system to surrounding, if it is transferring, it is represented as in the negative way. Remember, As I said, I'm taking in the example where water is kept in a large reservoir and also we are putting the huge heat reservoir to that so that heat will be get absorbed and initial and final temperature which is also get changes, but volume is not getting changes because it is kept constant. Okay, by considering that, if you see that heat transformations from the surrounding to system, it is in a positive way. From the system to surrounding, it is in the negative way. Okay. Lastly, we have most important one, that is a first law of thermodynamics. So it is very, very important to understand the first law of thermodynamics, which is also known as law of conservation of energy. What is the first law of thermodynamics says? So it says that the energy is neither be created nor be destroyed, but it can be transferred from one form to another form. So energy can neither be created nor be destroyed, but it can be transferred from one state to another state. Or you can say that the energy of an isolated system is constant. It is said to be first law of thermodynamics. Okay. To explain the first law of thermodynamics, I consider the system where it is having a internal energy U1. Okay. So I am considering a system where it is having the internal energy as U1. We know that the internal energy of a system can be increased by two ways. One is by applying the heat, one is by doing some work. Okay, so I am considering a system where it is having the internal energy U1, and this internal energy of a system can be increased in a two way. One is by supplying the heat, other one is by doing the work on the system. Now we know that after considering this, what will happen when you apply the heat and when you are doing some work, the internal energy of the system will be equal to U2. Correct now? So what happens? So when you are applying the heat and when you are doing some work on the system, the internal energy of a system will be changes to the U1 to U2. So now I can rewrite this reaction as U2 is equal to U1 plus Q plus W. Okay. Now if I taken out the U1 outside, U2 minus U1, which is equal to Q plus W, and U2 minus U1, it is nothing but a change in internal energy at a initial state to the final state, and it can be represented as delta U, which is nothing but a Q plus W. So this is a representation of first law of thermodynamics. So the change in internal energy of a system is obtained by, or it is always equal to the heat is supplied onto the system and work is done onto the system. So this is how we can clearly derive an equations for the first law of thermodynamics. What does this first law says? It always says that energy is neither be created nor be destroyed, but we can transfer from one form to another form. And remember, if you consider any system, the internal energy will be U1, and this internal energy can be altered in a two way, either by supplying the heat, either by doing some work onto the system. If I supply the heat, if I do some work to that system, what will happen to the internal energy? It will also changes from U1 to U2. That is why I have written this reaction as U2 is equal to or equal. That is why I have written this equation as U2 is equal to U1 plus Q plus W, or you can rewrite it as U2 minus U1, which is equal to Q plus W, or U2 minus U1, which is nothing but change in internal energy at initial state and final state, and is represented as delta U, that is a change in internal energy. So hope you all understood with the first law of thermodynamics and also the topics which I covered in this session. So in the next session, we are going to deal with the applications of first law of thermodynamics. Hope you all understood with the session. I'll come back with the next topics of this unit. Till then, take care, be safe. Thank you.